Welcome to the Aviation Pros Podcast, the go-to platform for professionals in the aviation industry. Powered by AviationPros.com, the leading source for comprehensive news, insights, and data on airport operations. Whether you're focused on airport management, improvement programs, ground handling, equipment, MRO, or FBO operations, we've got you covered with the expertise and resources you need to stay ahead.
Hello, everybody. This is Jenny Lesko-Hare. I'm the editor of Ground Support Worldwide, and today I'm here with Damien O'Regan, Product Strategy Lead at Enatel, and he's going to talk to us about some technology that facilitates charging GSE on ramps. So, Damien, why don't you start by telling us about Enatel's technology and its role in facilitating the adoption of charging infrastructure that supports mixed fleets?
Sure. Hi, Jenny, and thanks for this opportunity to share the perspectives of a charger manufacturer. I'd like to probably start with my role because it helps shape how we think about charging infrastructure. I've been involved in global industrial battery charging for almost 30 years now. I lead product strategy at Enatel, and the simplest way to describe that is it's my job to provide visibility, recommendations, advice through research, knowledge, and market engagement, which makes sure that we're solving the right problems and that we don't develop or we don't create a constraint tomorrow. An approach that's always stuck with me comes from Michael Porter, who said the essence of strategy is choosing what not to do. And I think that's especially relevant in electrification, where there's no shortage of technology options, and some of it may add complexity and it may limit future choices. A little bit about Enatel. Enatel is a global designer and manufacturer of industrial battery charging technology. Since 2018, we've been part of Ideal Industries, which is a 100 plus year old family business, which is headquartered in Illinois. Enatel's been developing and manufacturing battery chargers now for some decades. We have many hundreds of thousands of chargers and systems deployed across material handling, telecom networks, and other mission critical environments. Where uptime isn't optional, it's really essential. So we're probably not a household name. A lot of our products are private labeled through OEMs and sold via a network of channel partners. One of the most relevant experiences for us was the evolution of mobile networks. Battery chemistries were changing, architectures were changing, and we had to help them upgrade without rebuilding their electrical infrastructure. But a consistent mindset across multiple sectors is that, it's about making the most from the infrastructure you have. And this is directly relevant to airports today, perhaps even more so when we think about the timing, the impact. Reality is that most airports aren't transitioning towards mixed fleets. They already have mixed fleets. Which is a long-term reality. There's legacy diesel, early lead acid, first generation lithium, and now the newer high voltage lithium vehicles, all running side by side. Different voltages, different connectors, different chemistries, different duty cycles, and this fleet keeps evolving. On highway and off highway architectures all meeting. So I would say that electrification at airports started as being fleet-led, where airlines, OEMs, and handlers bought electric equipment, and then the chargers followed. But I think as scale increases, electrification has become more about being infrastructure aware, because it now must consider grid capacity, load management, and long-term planning. And this is not dissimilar to the challenges that we see in electrifying and automating our warehouses around material handling. We'd like to think that operators shouldn't have to rebuild infrastructure every time the fleet changes. So the role of the charger, in our role, is really to absorb that complexity. That's why our chargers were designed to support any chemistry across a wide voltage range from 24 to 96 volts. And it means that operators aren't locked into a single technology path. They don't have to make premature decisions about where their fleet is heading. The other point is, I think that modularity plays a big part of that philosophy. It allows operators to start small, add capacity over time, instead of buying new hardware as their fleet grows. It's really a sensible way of future-proofing and scaling. The charger chosen today really shapes the success of the infrastructure transition. It determines how flexible you can be and how easily you can scale, how much freedom you have in your fleet strategy further down the road.
Am I correct that you are referring to Intel's the outdoor charger is the technology that we're talking about? Is that correct?
That's correct. We've got a range of chargers, both indoor and outdoor. So for any GSE applications that demand indoor charging or outdoor charging, yes. But yes, we do have an outdoor charger as well.
Okay, thank you for that clarification. But it is, for the listeners who may not be familiar, it is I will let you describe it, but what does the technology look like?
So it's it's a large box, really. Simply put, it's a cabinet that's been tested to various compliance requirements, NEMA 3RX, and it's an IP54 enclosure. And within that enclosure, we have power electronics. So we have modular battery charging modules, which allow scalability and continuity. So if a module were ever to fail, the charger is still operational. So it's not offline. And it's simply replaced a hot plug. You just open the door, replace a module in a couple of minutes. And yeah, it's flexible, so it has this versatile functionality built in, so it adapts to any battery voltage and capacity and any chemistry. Yeah, so it's quite unique, and it's also highly efficient. So it's over 97% peak efficiency, which is industry leading, and we were first in the US to satisfy the CEC efficiency requirements in material handling. So we've really taken a well-proven architecture, which was demanded in telecommunications originally, that foundational modularity, scalability, continuity, high efficiency, and versatility, and have really just applied that into first material handling and now into GSE.
So for ramp teams that are thinking about charger placement from an operational standpoint, what would be your recommendations, or how can they approach that?
From a operational standpoint to placement, charger placement?
Yes.
Yeah, so I can talk to this really based on what I've been told sort of directly and anecdotally. I guess some of the easiest way to think about charger placement of chargers is absolutely strategic. So where a charger lives on the ramp, it affects vehicle availability, turnaround efficiency, it affects workflow. I think the first step should always be a power audit, which is particularly relevant today. Before anything is installed, operators need to understand the available capacity at each location, what the load profile looks like across shifts, and the best placement is where operational need and electrical reality overlap. A good starting point, I think, is deploying chargers on the highest utilized vehicles, which could be baggage tugs, for example. And that may be where you get the biggest operational benefit, the clearest data on how systems behave based on today's technology. Dual port chargers are also worth mentioning. Within space constrained environments, they've been popular in some markets. Serving two vehicles from a single connection reduces that wiring overhead and physical footprint. And then there's the environmental side, the outdoor rating, ensuring sufficient weatherproof, the construction is compliant to various standards. Ours is IP54 and NEMA 3RX, but it then gives operators placement flexibility. So you can put chargers where they're operationally needed and have the utmost confidence in their performance. From a ramp perspective, chargers, the placement isn't really about distance. It should be about time, and we've certainly seen that in the context of material handling in large distribution centres, where if a driver has to walk out of their way or remember to plug in, the charger really is too far away. So the best locations are where equipment naturally pauses around gates and staging areas. A simple rule is if a driver has to remember to charge, then the placement's probably wrong.
You mentioned, I think, a power audit is how you put it. How does this process work when someone invests in this technology? Does someone from your company come out and sort of assist in the engineering of it, or how does this process look?
We really, as a specialist in manufacturing and supporting, we have a network of authorised representatives, so partners in market, and they would be involved in that process. We have a culture of being customer advocates and working very closely with them. So we do have a support team that is involved in that process with these companies, and they really need to get on the ground and provide sort of eyes on their on these facilities and understand the technical the limitations, which are really emerging at the moment. Particularly, much of this infrastructure just was never designed, facilitated around electrification. Again, this isn't dissimilar to what we're seeing in many other sectors, but a power audit looking at circuits and capability really helps provide the full picture.
What are some best practices for integrating charging into turnaround cycles without adding delays or complexity for ground crews? Because you had mentioned, like, if somebody forgets to charge, there's a problem. Are there best practices that you can talk about?
Yeah, I think the goal must be to build charging into the natural cadence of operations. So you're not creating a separate workflow around it. And I think there are really two layers to that conversation. It's how we integrate charging with the products and infrastructure that we have today, but also how we can make the decisions we're making now won't be barriers to future architectures, particularly with the emergence of things like automation, wireless charging, and more intelligent energy systems. So if we look at the drivers behind electrification, which, regulatory pressure, sustainability commitments, operational efficiency, it's really that last point, operational efficiency, where I think that charging practices really matter. Operational efficiency is about keeping vehicles available without adding friction. And one way is opportunity charging. It's probably one of the more effective ways to do that, plugging in during break times or idle times, rather than waiting for deep charge cycles. Keep vehicles ready without disrupting turnaround. So little and often works far better than big infrequent charges. Another point would be data visibility. When supervisors can see battery state and charge status across the fleet, they can make smarter decisions about which vehicles are ready, which may need more time. And so it removes that guesswork, avoids those moments where a vehicle may look available but isn't actually available. And ground crews, they don't think in kilowatt hours, they think in availability. If the vehicle is ready when they need it, then things operate more smoothly. Another really big point, I think, is standardization. When chargers have consistency across different assets, the same connectors, the same user experience, crews don't have to relearn things vehicle to vehicle. Charging becomes almost invisible, which is exactly what we want. So the best practice is really to integrate charging into today's operations, but also make sure that the infrastructure you're putting in place leaves room for the inevitable next generation of technologies.
Are operators using charger or battery data effectively yet? Is that something that's still an opportunity to come, or how would you characterize that?
Yeah, it's an interesting question. I would say right now, most operators use charging data reactively. So they're looking at alarms and basic reporting. I think the bigger opportunity is around operational intelligence, which means using data to identify bottlenecks before crews will feel them, aligning charge profiles with real duty cycles, reducing battery wear, and managing load as fleet scale. And for most operators, this is, I think, still largely untapped, and it's a huge opportunity as fleets grow. We're moving quite quickly, I would say, towards connected infrastructure where the charger becomes a data node in a broader energy management system. So chargers like ours have API connectivity capability built in, and this allows operators to track energy consumption and battery health across fleets. And this is going to become critical as fleets grow beyond what can be managed manually. Having visibility into degradation trends before they cause downtime is the kind of predictive maintenance capability that changes how fleets will run. And then there's fleet level power management. As fleets scale, aggregate load becomes a constraint. So we then enter the realm of smart charging, managing the timing and the charge rates to avoid demand peaks will become increasingly necessary. The chargers, I think, that are selected today should be capable of participating in these coordinated systems because the question stops being, is my charger working? And it becomes one of, is the system working for my operations? And I don't think electrification fails because of hardware. I think it fails when infrastructure ignores how work is actually being done.
That's a good point. How would you describe where we're at right now with, it from my perspective, from observing the industry, it really seems like electrification is just gathering so much steam. But there's this, the charging question is ubiquitous. But how would you describe where we're at? Like how much more runway do we have to get where it's going to be full acceptance, or are there still some laggards out there? How would you describe that?
I think that we can draw parallels to the material handling industry. I think with the electrification we've seen within that sector, electric forklifts been around for 100 years. Batteries, lead acid batteries have been around for longer. So I think that what we're seeing in that industry was very much driven by regulatory. So, operating forklifts in closed environments and indoors So you couldn't have internal combustion, so you moved very quickly to electric. I think that was a driver there. I think that from a financial perspective, from an operational perspective, electric has proven that there are cost benefits now. We're particularly seeing that from a on-highway perspective, and the increased appetite, consumption of electric vehicles on highway. But off-highway, I think, has been made more complicated because we are seeing this clash of both on-highway power architecture and off-highway power architecture. I think the on-highway sector is very well defined from a standards perspective, from a connectors perspective. The charging infrastructure is very well baked. Off-highway has been made more complicated by this mixture of taking powertrains from electric forklifts and electrifying vehicles, tugs, and then you have pushbacks, which are sort of moving more into that high voltage architecture. So we're seeing two very different sort of realms. I wouldn't say conflicting, but I think that there's more definition required, more standardization required. Each have their own position, their own right. I think that low voltage is catching up from a standardization perspective. We're seeing that with some of the new standards, LICOM being one, which is standardizing, connectors and protocols. But I think that the infrastructure will ultimately be one of the major limitations in this as we move through this transition. I think the infrastructure, who owns the charging infrastructure, is at a point of transition, moving originally from sort of airlines and OEMs and ground handlers. I think that airport companies, facilities are probably better positioned to own the infrastructure if we look at some sort of relative sectors. But that's going to need investment as well, because the infrastructure, and again, we see this in material handling, to electrify a warehouse today, retrofit electrification is extremely complicated. Transformers need upgrading. Automation and electrification does introduce complexity.
If you had to offer advice to any, airport planners or ground handling firms on how to kind of embrace updating their infrastructure or getting into this, what would be some things you would advise?
I guess my advice would really be encouraging engagement by airports or their intermediaries directly with charger manufacturers and their authorized representatives. I think the bigger theme is that the chargers shouldn't be an afterthought. It's part of the infrastructure, and when facility owners and users treat it that way from the start, I think that everything downstream becomes easier. I think that there's been a risk that we're seeing chargers that have been sized to theoretical peak power instead of real duty cycles, and that leads to problems. It can lead to idle charges or queues during peak periods, or chargers being placed where layouts may have looked good on paper rather than where they actually where work actually happens. So I think that there's high cost in correcting some of these mistakes later. It's moving chargers, upgrading wiring, adding protection, rerunning conduit. It's disruptive and it's expensive. So I would really encourage that early engagement, as early in the process as possible.
How about looking into the future? What might be coming soon for this technology? Is there anything that you can preview?
I think that for us, we've seen some trends early. I mentioned sort of standardization, this need for standardization. I think that there's particular appetite and need for that right now. So LICOM, Inatel, saw that very early on and initiated a universal communications protocol, which and it's specifically to support mixed fleets and open ecosystems, and that's being industry ratified. So that's something that the industry would use. So I think standardization is something that has to be implemented. From a technology perspective, there's this constraint of the grid, and at many airports that will be the limiting factor. It'll be more limiting than the charger technology. So we are developing sort of the next generation. We're developing sort of distributed charging architectures that combine grid power with storage. And that idea is simple. It lets operators work within their existing electrical limits. It shifts loads off peak. It smooths demand, delivers the power profile that vehicles actually need without relying on these large centralized upgrades. And because these systems are distributed, they can sit where operations actually happen. They introduce resilience and maintain charging capability through grid interruption. And so I think that's really exciting, and I wish I could talk more about it, but I wouldn't be allowed. But I think that those sorts of sort of new thinking and applying that sort of technology to these challenges and problems is a far more appealing, and it's more rapid. The reality is that transformer upgrades and grid upgrades are expensive and will take years. So I think that there's some exciting solutions coming.
Well, I hope you'll keep us posted about that. I thank you for the information that you've given us today, Damien, and I hope we'll have you back sometime for an update. Thank you.
Excellent. Great. Thanks, Jenny.
Thanks for tuning in to the Aviation Pros podcast. Stay ahead in airport operations and leadership by subscribing to our Airport Business Daily newsletter, your go-to source for the latest industry insights. And don't forget to explore even more at AviationPros.com, the home of exclusive content for aviation professionals like you. I'm Joe Petrie. We'll catch you next time.